This video is intended as a guide only and does not take place of proper training by qualified instructors. For a more complete understanding of the fusion process and machine operation, we encourage you to attend one of the many classes offered through McElroy University. Visit our website www.mcelroy.com/fusion for a complete listing of class offerings.
Hey, I'm Brandon Jackman, a project engineer with McElroy Manufacturing. Today we are here at the end of our production line where this Trackstar 900 has just finished being assembled. We're going to use this Trackstar 900 to fuse some 36-inch IPS DR 13.5 pipe while following the guidelines outlined in ASTM F2620. This is the generally accepted standard for fusing polyethylene pipe in the United States. However, there are other standards that may govern your process. Make sure that you understand the parameters that you are required to fuse to on your job site. Before we head out to our job site, we need to talk about safety, especially pertaining to large diameter pipe. Please make sure to read the operator's manual, which covers these safety considerations and more in great detail. Most accidents involving large diameter pipe have had very little to do with the fusion equipment or even the type of pipe they were fusing. People have been seriously injured because they did not pay attention to basic safety precautions. Therefore, make certain you do the following. Make sure you stay out of the way of heavy equipment and pipe. Only use properly sized equipment to move and load the pipe. Make sure you understand and use proper lifting and moving procedures for pipe and equipment. Avoid bending the pipe or putting the pipe in a bind unless you have the proper safety equipment. The pipe stores energy and will recoil when that energy is released. Also, take a look at the machine you'll be using and make sure it is in good working condition and as clean as possible. The operator's manual covers cleaning and use in detail. That being said, let's learn how to properly use this piece of McElroy equipment.
For this demonstration, I am using a McElroy MegaMac Polyhorse pipe handling system. This makes my life much easier as it helps to control the pipe and loading process. The MegaMac Polyhorse improves efficiency in loading pipe, thus allowing you to make more joints in less time, and greatly lessens the chance for damaging your fusion machine while loading and unloading large diameter pipe. Still, I will make sure I do not walk past the safety cones. That helps me stay out of the way of moving pipe. Make sure you have read the operator's manual, and then take a look at the machine you will be using to make sure it is working properly and is as clean as possible. The operator's manual covers this in detail. It is a good idea to double check that you have the correct size and number of inserts for the pipe you will be fusing. If you aren't using a Trackstar, make sure your generator is properly sized for the fusion machine and altitude of your site. There are many different ways to set up your job site depending on your situation. Whatever the case, make sure the pipe is aligned with the fusion machine and properly supported on both ends of the fusion machine. I will begin by starting the machine. Since the Trackstar 900 is powered by a diesel engine, you must preheat the glow plugs for 5 to 10 seconds if it is 50 degrees Fahrenheit or below. Once the machine is running, flip the throttle switch to high idle and then turn the heater on. It is a good idea to check the set point of the heater. Use a clean, dry, lint-free cloth to clean the fusion area. We want to make sure we get rid of anything from the fusion area of the pipe that can contaminate the fusion both inside and out. Now it's time to load the pipe. On this job site, we are using our MegaMac Polyhorse to aid in the loading process. With the pipe as level as possible, feed it into the jaws using the pipe lifts to help you. Once the pipe is set into the machine, lower the pipe lifts all the way. On a Trackstar 900, I will make sure I have about 1.5 inches to 1.75 inch extending past the inner jaws. This will allow enough pipe to extend past the jaws to get a complete face-off. It is generally best to make sure that we are facing off the same amount of material from each pipe. This helps ensure that the OD in the fusion area is as close as possible, as the ends of the pipe tend to neck down. You can use the carriage to make fine adjustments to the pipe's position. Then close the upper jaws and use the clamping cylinders to tighten the jaw around the pipe. This applies pressure that will hold the pipe securely with the aid of the serrated inserts. Anytime I clamp or unclamp, I will keep my hand on the clamping cylinder handle. Shift the indexing valve to allow the facer to fit between the pipe ends. Lower the facer in place. Shift the pressure selector valve to face and dial the corresponding pressure reducing valve to minimum. Make sure the pipe ends aren't touching the facer, and then turn the facer on. Shift the carriage control valve to close. We want to face with the minimum pressure possible. Apply only enough pressure to allow the blades to shave ribbons of material from the pipe. If the facer begins to struggle, shift the carriage control valve to neutral and turn the pressure down. Facing slowly is really helpful in achieving the best face-off possible. Face all the way to the mechanical stops. This will square up the facer. With the jaws still against the stops, shift the carriage control valve to neutral. Wait for the facer to spin a few more complete rotations, and then turn the facer off. Open the carriage and remove the facer. Now inspect the pipe ends to ensure at least a full ribbon of material has been removed. Remove any remaining facer ribbons or shavings from the fusion area. Bring the pipe ends together to check for proper alignment. Use a slim instrument such as a fusion pressure calculator and run it across the two pipe ends where they meet up. If the alignment is within 10% of the wall thickness, we can continue. If not, I can adjust a jaw stop. If I need to make an adjustment, I must reface the pipe ends. There should be no visible gaps between the pipe ends. Next, we need to measure drag pressure. We do this by opening the carriage, with the pipe loaded, until the pipe ends are about 2 inches apart. Shift the pressure selector lever into the middle position. It is labeled heating. Turn the center pressure reducing valve all the way counterclockwise. Shift the carriage control valve to close. If the carriage moves with the pressure reducing valve backed all the way off, then we will use 30 psi for our drag pressure. If it does not move, slowly increase the pressure by turning the pressure reducing valve clockwise until the carriage starts to move. Quickly turn the pressure reducing valve back down until it barely moves. Read the pressure on the gauge or the data logger. This is your drag pressure. In this case, we'll be using 70 psi. Leave the heating pressure at this setting. The fusion pressure can be calculated using the included fusion pressure calculator. Always add drag pressure to calculated pressure. ASTM gives us an interfacial pressure range of 60 to 90 psi, so I need to know the corresponding gauge pressure. There is another video that discusses how to use the fusion pressure calculator. Please feel free to pause this video and view it if necessary. It can be found at www.mcelroy.com/fusion. McElroy also offers an app for your smartphone called McCalc. This app calculates pressures based on the information you give it about your pipe and is available for both Android and iPhone operating systems. Using the fusion pressure calculator, I arrive at a target of 781 psi. Shift the selector valve to fuse and set the pressure using the bottom pressure reducing valve. Now is a good time to check and make sure the pipes do not slip in the jaws by bringing the pipe ends together at fusion pressure. If they slip at all, we must reload the pipe and reface it. It is just about time to heat our pipe, but before we can do that, we have to make sure that the fusion area is clean. Wipe away any debris from the jaws and pipe, and be sure to not touch the face of the pipe as it's freshly faced and as clean as it can be. Open the carriage just enough so that the heater fits between the pipe ends. Shift the indexing valve to line up the heater and then pivot it partway into the carriage using the heater pivot valve lever. Wipe down both sides of the heater with a clean, dry, lint-free, non-synthetic cloth. Use a pyrometer to check each side where the pipe will come in contact with the heater. ASTM specifies that the heater surface temperature be between 400 and 450 degrees Fahrenheit. Just a quick note, the thermometer on the heater should not be used for this purpose. It tells the internal temperature of the heater and is just an indication that the heater is hot. Pivot the heater in the rest of the way. To begin the bead up, bring the pipe ends against the heater at fusion pressure and verify complete contact. Wait until there is a slight indication of melt all the way around the circumference of both pipes. Then drop the pressure to drag by shifting the pressure selector valve to the middle or heating position. Wait until the gauge or the data logger shows that the pressure has dropped all the way down to drag. We do not want any pressure trapped in the cylinders. Give it an extra few moments and then shift the carriage control valve into neutral. This is the beginning of the heat soak. it is crucial that no pressure is applied between the pipe and the heater. Just watch the pipe and verify that it stays in contact with the heater. Any application of pressure will cause the heat to not properly penetrate the pipe. For 14-inch IPS and larger, ASTM specifies a soak time of 4.5 minutes per inch of pipe wall thickness. We are fusing 36-inch IPS pipe, which has an outer diameter of 36 inches. Divide this by the DR of the pipe, in this case 13.5. This gives the actual nominal wall thickness of the pipe. Take that number, 2.67 inches, multiplied by 4.5 minutes per inch of wall thickness, and we get a minimum soak time of 12 minutes. The heat soak will be complete when the specified heat time of 12 minutes has passed and the minimum bead width has been reached. You can find your bead width in ASTM F2620 based on the actual OD of your pipe. Our pipe has an actual outer diameter of 36 inches, therefore we know to look for a bead of 9/16 of an inch. For this pipe size, ASTM specifies 25 seconds maximum to open the carriage, remove the heater, and to close the pipe ends onto each other to make the fusion. Remember that this is the maximum. The faster we can safely do this, the better. Let me take you through this process in detail. Shift the pressure selector valve into the fusion position, and then shift the carriage control valve to open. Open the carriage just enough to allow the heater to be indexed over and pivoted out without hitting the other pipe end. Index the heater to the right to strip it off of the pipe. Pivot the heater completely out. The heater needs to be removed without disturbing the molten material, so be sure not to bump the pipe ends while removing the heater. With the heater now removed, we can see the pipe ends clearly. Closely inspect the pipe ends to ensure a proper melt. The visual indications of a good melt are a flat and smooth surface with no unmelted areas. If the surface is even slightly concave or is speckled, or if any of the material stuck to the heater, we've got a problem and the fusion process must stop. As you are completing the visual check, begin closing the carriage. Leave the carriage control valve in the closed position for the remainder of the fusion process. The joint is now in the cooling process, and it is just a matter of waiting for the cool cycle to complete before we remove the pipe. ASTM specifies a cool time of 11 minutes per inch of pipe wall. We are fusing 36-inch IPS pipe, which has an outer diameter of 36 inches. Divide this by the DR of the pipe, in this case 13.5. This gives the actual nominal wall thickness of the pipe. Take that number, 2.67 inches, multiplied by 11 minutes per inch of wall thickness, and you get a cool time of 29.33 minutes, or 29 minutes and 20 seconds. Once the cooling cycle has completed, shift the carriage control valve to neutral. Grab and hold the clamp cylinder handle and open the clamps. Then open the jaws into those clamps. Repeat the same on the movable side. Then open the carriage. Now we will open the jaws all the way. Make sure the heater and facer are out of the way. Hold the clamp cylinder handle, close the jaws, pivot the clamps out of the way, and then open the jaws. Inspect the joint. A good joint will have a good double bead rollback with a uniform appearance on each side, and the bead will have rolled back touching the pipe. Check for any debris or pitting in the joint. If all is well, move on to the next joint. If you notice anything abnormal, cut the joint out and start over. Lift the fused pipe evenly with the pipe lifts. Make sure the fusion bead will clear the jaws. Pull the pipe through the machine using a piece of equipment that is rated for these kinds of loads. Make sure you are in contact with the driver so he can stop pulling when the next pipe end is close to the right position. Have the driver stop a few inches early. We'll use the carriage to put it in its final position. At this point, we are ready to start the process all over again and continue building our pipeline.
As you just saw, fusing large diameter polyethylene pipe with the Trackstar 900 is nearly effortless and goes quickly, especially with the aid of the McElroy MegaMech Polyhorse. Remember, a properly fused joint will be as strong or stronger than the pipe itself, so it is key that you follow the steps outlined in this video to ensure that your fusion is made to standard. Be sure to check out McElroy's many other videos to help with all of your fusion needs. Go to McElroy.com/fusion to find charts and other reference materials that may be helpful on your job site.